What's up guys, Roland here. This time on 3D NerdStop we're going to continue to work on our R2-D2 project. Alright guys, here we go. We're going to look at a couple things today. We're going to start with the Periscope for R2-D2, and we're mostly going to concentrate on the lift. As you know, we used the Periscope that I printed out last week. I did decide that I needed to reprint it for this one, and I'll kind of show y'all why. It's kind of hard to tell, but if you look at it, I had to change the angle of the top of the Periscope up here because this dome is slightly different than the angle of the angle he put on the Periscope, so I had to change it. So I had to modify the top of the Periscope to work with the dome we have here. So what we're going to do is we'll move the dome here real quick. And this is our Periscope and lift. Okay, it's a fairly simple mechanism. This thing's going to run on a stepper motor. The Periscope is also going to have a stepper motor underneath it that'll spin the Periscope. So when the Periscope goes up, you can spin it around using that stepper motor. Okay, so we have pretty simple here. We have a lift, we have a mount, which inside has a lift with a track inside of it, with a shuttle inside that. Now we have the stepper motor with a wheel on it here, and this wheel is designed so I can hook a line to it, a piece of thread, fishing line, whatever I decide to use. So I can hook it into it, and it'll go around it, and then go from the wheel up to this pulley, around the top of the pulley, down, through the little hole down here. Then it would come out the other side here, and go straight up to a post that'll stick out here, which is holding the pulley on the other side on, and tie off to it. Okay, so what would happen is this wheel spins, tightening this string, is it'll pull this upwards, and should pull it all the way to the top. Okay, so once it reaches the top, then we'd be able to spin this. Now we do have to be careful when we do program it to spin, because our wires, as you can see, there's not a lot of room for wires to run up inside this, the way it's designed. So, I mean, I'll have wires going up in it, but they're not going to exactly be able to spin 360 consistently. It'll have to only spin like 180 each direction. But that's okay. We can make that work. Alright, so I took all these and cut up all the parts. I also cut up the Periscope into a bunch of different pieces. This way it'll make it easier to print with less cleanup, and I'll show you all that when we switch over to Cura and I show you all the pieces. Okay, the other thing we're going to work on is our life scanner. Alright guys, so here's the life scanner. Now I did get the idea and concept for how I designed and built this from James from XRobots. If you've never checked out his channel, it's wonderful. I'll put a link to it in the description down below. He does all kinds of 3D printing and makes all kinds of cosplay stuff. You know, he's made R2, he's made all kinds of stuff. I mean, the Hulkbuster outfit, he does a lot of really, really good work. He also goes through all of his Arduino code that he uses and everything that he designs. He tells you how he does every little piece of it. So I got the design concept for him on how to build this. Okay, so basically the way this works is this basically has like a rack and pinion in it, which is basically, we'll remove the dome here real quick, which is basically a gear with a flat gear. Okay, so as this gear spins, it'll lift this entire piece. It'll lift this entire piece up. Okay, so as it does that, what you do is you have a string tied to the mount here. Let's see, scroll in here, so you have a little hole right here, so you can tie a string to it. That string would go up and over top this pulley, which would then go down through this hole, just like we did on the other one, out the other side, and come up and tie off up here. I have a pulley up here right now, so I could have it come up and go around the pulley and tie it off at the end here, which I have a hole right here for. I could do that, which is probably how I'll do this one. Okay, but how it works is as this part here moves up, the string will tighten because it's getting pulled away from the mount here. Okay, so as that tightens, both pieces will extend. that'll allow it to extend further and allows it to go higher, so you get twice the height out of this. So this should let this life scanner go higher than the Periscope does, which is kind of the idea. You do want it to go a little higher because that's how R2's scanner works. Okay, so we also have the hinge. Now this is the hinge that pops up the little pie piece at the top, so you can see, so it'll move the pie piece out of the way so this can come up. And that works on a simple servo with a push rod here that's connected to this, and this with the dome on, you can see, oops, you can see right here is connected to the bottom of the pie piece, and that'll push the pie piece up and out of the way, which will pivot up and out of the way, so when this comes up, it'll go past it. Okay, so it's pretty simple. This is a bunch of pieces, and we'll go through all the pieces shortly here when we go over to Cura. Now, one thing we do need to do is I do want to make all the pie pieces open, except for the one that has the halo projector in it, or the one with the Periscope in it, because, well, the halo projector takes up an entire pie piece, and the halo projector has its pie piece attached to the top of it. So we are going to need some hinges for the other, I believe it's 3 pieces on his dome. I believe he has 3 more pie pieces up there. So what we're going to do for that is we're basically going to take this design and we're just going to use the hinge parts. So if I switch over here and I turn off the body, we're basically just going to use this part. Now, I don't really want to print out all this plastic. This is a lot of plastic to print just for having the hinge and the servo mount. So what we're going to do to save ourselves a little bit of plastic is we're going to come up to the front of it here, and we're going to create a new construction plane, and we will do it on the face here, and scroll in a little bit and do it on the point here. So you can see that gives us a plane right across here. Okay, now this plane, if we want to, we can make it look bigger. The plane, this gold area or yellow area doesn't really matter. The plane's infinite in size. This is just a representation of how big, of where the area is and the plane it's on. Okay, so we're going to turn off a couple pieces real quick. We'll turn off like the hinge. We'll turn off the servo. We don't need to see it. We'll turn off the push rod to get them out of the way. So that just leaves us with the mount. So basically what we want to do is we want to take this mount and cut it basically from this corner, I would say, or maybe halfway up between here, and cut it straight back. Okay, so that'll leave us just this piece with the servo mount and everything. That's all we need for the other pie pieces. So of course, in order to do that, the first thing we'll do is we will draw a line. Now we have to select the plane we want to put a sketch on. So we'll say we want to put it here. Now if we rotate this just a little bit, we can see that right about here, say right about here, is about where we want to draw this line and have it go straight across. Okay? So we can do that. As we can see, that just puts one line straight across there. So we can stop that sketch. Now this is something I learned on how to slice parts up in here. It took me a little while to figure this out, how to cut parts up and make different pieces out of it. So basically, like when I drew this, this is 2 pieces now here. And originally it was one solid piece and I had to cut it in half, so it made it easier to print. So I'm going to do the same thing here. I'm going to slice off the top of this, which then again will make this easy, will make it so I can only need to print the top part of this, so I don't have to worry about the rest of it. So the way you do that is, instead of being in model mode, what you do first in model mode is you draw your line across the face of what you want. Alright, so after you got the line drawn and you have it where you want it, you have to switch from model over to patch. Okay, then I want to go up here and go from create to extrude. Alright, then I have to come over here and I have to put focus on the component that I want to slice. Okay, so I'm going to do that. I'm going to select this and then I'm going to extrude it through it. So you see how it's creating a plane through it? Then I can say OK. Now sometimes it leaves the focus, sometimes it takes it away. I'm going to put the focus back on the body that I want to cut. It's actually 2 pieces I want to cut, but that's okay. I'll put it back on the component I want to cut. Okay, and then I'm going to go back to model, and then under modify, you have split body, and you see it splits it upon whatever shape you have to split it at. So I'm going to say I want to split body. I want to split this body and this body based on this plane. Okay, so when I click OK, okay, now I can switch in here real quick and go to bodies. I can turn that off. Alright, now if I want to, I can turn that off, and I can turn that off. And as you can see, it left me with just the pieces that I left on top. So instead of it being 2 pieces, now it's a 4-piece body. Alright, but I don't need these two. I'm not going to use them, so I'm just going to turn them off. So these are the only 2 pieces I really care about, other than the hinge and the push rod. Okay, these are the pieces you need. We'll put this out here. These are the pieces you need to make the hinge for the outside. Okay, so this is the hinge I'm going to use for all the other pie pieces inside the dome. Okay, I know that was a lot of information, but that's it's the easiest way to slice up a model. All right, now to export the models, I've shown you all this before, but I'll be happy to show it again. Is when you go to export, you go up here to where it says make, and you tell it what you want to do. I want it to make a 3D print. Okay, so I'm going to select the piece I want. Okay, I don't want to select all of them because I don't want them all in one STL file. I want them in separate ones so I can import each one individually so I can lay them out the way I want them. Okay, I use Mesh Mixer, and I click OK. Okay, and it opens up Mesh Mixer real quick, and all you have to do is click Export. Okay, and then tell it where you want to export it to. Tell it what format you want to export it in. So I want STL binary format, which is the one I use the most. Then you name it what you want to call it and click Save. Okay, and then that's all you have to do. And don't save that one, and I can go to the next piece and say, okay, I need this piece. I need to export this piece. Do the same thing, and I can go through all the pieces this way. Now, the one thing you have to realize is every time you come in here, you're going to have to surf back to where you want to put the file. And you're going to have to change the file format every time so you can find it. Okay, now you can do where I select this one and say okay, then I can come over here and I can select this one and say I want to export it and say okay, then I can say I want to select, I want to select this one, I want to make a copy of it and say okay. Okay, now as you can see here, I have all of those pieces opened up. Now I don't really need these 3 pieces. I'm going to do it anyways here for the push rod for it because I already have these models from when I did the life scanner. But we'll go ahead and put these out here because I am going to put all this stuff in Thingiverse. So you can just go download these models if you want them. Alright guys, so there you go. So we've created all those parts. Alright, so now what we need to do is we're going to need to jump over to Cura. So let's jump over to Cura real quick. Okay guys, so now that we've done all that, now we can open that hinge up here in Cura. So we'll come in here and grab all the hinge parts that I just created. And you can say open. As you can see, it'll put them all out here for us. Now, we just need to take these pieces and lay them flat on the bed. So we'll rotate them. Put that roughly where we want it. Make sure it lays flat. Pull this piece out. Okay, now that we have all that rotated, we're going to place these out on here to bed. Now this is on the CR10. Right now I'm using the CR10 because I'm having a couple issues with my Robo I haven't gotten fixed yet. So I'll be getting those fixed here soon. It's just some minor issues. I need to do some maintenance on it, and I just haven't done it. So I'm using the CR10 right now for all my printing, which is a good thing to have a backup printer when your main one isn't working properly. So I can lay this over here and take this piece and spin it around. Something like so. Oops. Let's set it over here. Then we have our push rod, and we can put it down here. Now, of course, I just did all that, and now I need to come in here. I need a total of 3 of these. So I need to multiply each of these by 2. There we go. So we can see we now have them all here. Let's spread these out a little more and make it a little bit better. Oops. Ooh. That was not pleasant. The one thing the old Cura does that I don't like is if you accidentally drop a piece in the wrong place, it'll really spit you all over the place. Soon I will be upgrading to the new Cura and seeing how well it works with all of this. I just have not done it yet. Okay, so there we go. So we have all of our pieces laid out, and this gives us 3 of each hinge, which should be enough to take care of the rest of the dome pieces that we need to open. To our standard settings on this, we're going to do a layer height of 0.2, our shell thickness of 1.2, our top and bottom thickness of 1.2. Our fill density of 20%. We're going to print this at a 70 millimeters a second. Our print temperature is going to be 200 and our bed temperature is going to be 50. We are not going to use any support material on this. We don't need any. There's nothing that we're printing that should need any support material, which is one of the reasons why things are all sliced in half, so support material is not needed. Okay, but we are going to print everything on a raft, because I find on the CR10 that's the best way to get the best dimensions. Now, one of the things I've learned to start doing is to come over to the layers on these and go all the way down to layer 1 and make sure for every piece you have on the board that you can see a footprint for it. Because I found sometimes it'll look like a piece is laying on a bed and it looks like it's laying on the bed properly, but when it goes to print, it does not print the footprint for it, and it prints it at a slight angle and it messes it up. So I always come here and look to make sure I see a footprint that looks correct for every piece I'm going to print. Alright, if you want to, you can go up a layer or 2 on it too. You can go up to layer 2 and look at it. But I always make sure layer 1 has it, and then layer 2 looks pretty much the same. So as you can see, the first couple layers show exactly what I want. That's where all the pieces are. So I have started doing that way I can make sure the pieces are actually laying flat and laying where I want them. Alright, so we'll shoot that one over to we'll save that one off to an SD card, take it over to the printer, get the printer heated up and get her printing. But before we do that, I'm going to go through the rest of the models we're going to print out this week. Alright guys, here you go. This is the Periscope. As you can see, I told you I chopped it up into a bunch of pieces, so instead of having the Periscope in one big piece, now it's in a bunch of small pieces, so it will print better. We are going to do our layer height on this at 0.2, our shell thickness at 1.2, our top and bottom thickness at 1.2, our fill density at 20%. We're going to do our print speed at 70, and our print temperature at 200, and our bed temperature at 50. Now, I am not going to do any support material. I feel that this piece is going to print just fine with the overhangs it has. I don't really feel that it needs a support material, and that's just based off of some of the sample parts that I printed out to figure out how much I needed to scale him up, how they turned out. I really don't feel that I need support material because of how well they turned out. So I didn't use any support material on this model. Okay, as you can see, this says it's going to take roughly 17 hours and 13 minutes to print, which is 87.32 meters of material, or 260 grams. Alright, and the next thing we need to print out is the life scanner. As you can see, the life scanner here has got a bunch of parts. Alright, so we use the same settings for it. 0.2 layer height, 1.2 shell thickness and top and bottom, 20% fill density, 70% speed, print temperature 200, bed temperature 50, no support material, and we do print it all on a raft. As you can see here, all the pieces laid out for it. As you can see, this says it's going to take 15 hours and 18 minutes, which is 69.37 meters of material, or 207 grams. Alright, the other thing we got to get printed out this week is we need to get all the projectors printed out. The halo projectors that are on the dome. There's one on front, one on top, and one in the back. So there are a total of 3 of them. The ones with the holes around the base pieces you see, they have the 3 holes around the base pieces. Those are the ones that go on the front and back, and the one without holes are the ones that go on top. But the projector eye piece is the exact same for all 3 of them. Okay? So in order to print all these out, I'm printing everything on the same settings, but I am printing with a little bit of support material because the little eyeball face looking things in the back, the ones with the little holes in the top, the little dome pieces, they're not flat against the platform. There's a little bit of a lip underneath there, so it needs a little bit of support material. Okay, but that being said, this is going to take 18 hours and 55 minutes to print, which is 89.8 meters of material, or 266 grams of material. Alright guys, now that we've got all that done and all that stuff ready, we're going to save all of it off to SD cards. We'll take it all over to the printer, get the printer heated up, and get her printing. Alright guys, here you go. As you can see, I've got a bunch of parts printed out. On the left hand side of the screen you've got the life scanner, and on the right hand side of the screen you've got the periscope. I did just get finished printing out the projectors. This just finished. I have not got a chance to print out the hinges yet. I will get that done in the next day or so. The next video we're going to start priming and painting all this stuff, get it all sanded, primed, and painted. We'll get it all assembled. Once we do all that, then we'll get into the electronics. Alright guys, thank y'all for watching. If you like what you saw, please like and subscribe. Please leave a comment down below. I'd love to hear from you. Until next time, have a great day.